We are in section 3.3, electronic components. Typical electronic components include, and we have three groups here. I'm going to be looking at voltage sources, fuses, and circuit breakers, and this will be part A. And then we're going to be looking at resistors in a second section. That'll be 3.3b. And I hope to conclude this with capacitors, inductors, transformers, and transistors, and diodes. This would be in a third section, 3.3c. I don't think a D will be needed, but we're planning to do it as A, B, and C. Okay, first thing we're going to look at is batteries. Batteries. A cell is a standalone source of energy. A battery is two or more cells connected together to provide higher voltage and or current to a circuit. The more cells, the higher the voltage supply. Cells and batteries are rated by voltage and ampere-hour ratings, and AH stands for ampere hour. And 1 ampere hour means the battery can deliver 1 amp of current for 1 hour, or a quarter of an amp of current for 4 hours, or 2 amps of current for 30 minutes. And there you have lots of variation here, but the idea, this is the concept of an ampere hour. And here we have a symbol for a battery. The longer terminal here is the positive side, and the shorter side is the negative side. Fuses and circuit breakers. Excessive current flow in an electrical circuit may damage the circuit. Now that's probably quite obvious. You have too much current flowing through a circuit, it can actually, it'll overheat, and it can burn up and destroy components. Typical causes of increased current flow are low resistance connections outside the normal path of current flow. These are called short circuits. Fuses and circuit breakers provide protection from excessive current flow, and that is a schematic symbol for a fuse. Fuses are connected so that current flowing through the circuit also flows through the fuse. Okay, so here we have a fuse, and I suppose we could go in here and connect a battery. And we could come back over here and go up like so and connect a ground here, and we would have a circuit. So the idea here, fuses are connected so that current flowing through the circuit also flows through the fuse. So the fuse becomes a part of the circuit. A resistive link inside the fuse heats up when current flows through it. Excessive current flow causes the link to burn, okay, which stops current flow and protects the circuit. So in this case here, the fuse is in the circuit. If we're pulling too much current through this, then the fuse will burn, and we'll have an open at this point, and then current will cease to flow. A fuse that has burned open is said to be, and here's the term, a blown fuse. Fuses have 3 electrical ratings, and we're going to look at current ratings, voltage ratings, and response time. First of all, current rating. Max sustained current that can flow through the fuse without it opening. The voltage rating. The minimum amount of voltage required to arc across the fuse after it blows. Notice that is after it blows. The voltage rating of the fuse must exceed the highest voltage that can be expected across the circuit. If the voltage rating is exceeded, the blown fuse can arc, defeating the purpose of the fuse. Response time. When the current exceeds its rating, the fuse link will burn open. It takes a certain amount of time for the fuse link to disintegrate. This time is referred to as the response time. Response times vary from several milliseconds to several seconds, and due to the type of circuit, the response time will have to meet those needs. If you have real sensitive circuits, you may have a fast response time. Not so sensitive circuits would not need a quick response time. Fuses may be classified according to their appropriate response times, and we have three. There is the slow blow, the fast blow, and the normal blow. First of all, let's look at slow blow. These fuses are designed to withstand currents which greatly exceed their current rating as long as the overcurrent condition is only momentary. Short-term transients or surges won't typically blow this type of fuse, and the response time of 1/10 to 10 seconds. So there's a term that's slow blow. These are like usually in a household you would have slow blow fuses. If you have transients or surges in the voltage line, those will not blow. If they did, your household circuit would be, you'd have to be resetting the circuit breaker all the time, because surges and transients are really quite common. Then there is the fast blow. These have a very short response time. They protect sensitive electronic components like transistors. They range from sub-millisecond through hundreds of milliseconds. So these could be less than a millisecond of time in the response. They're very fast. And then there are normal blow, response time between slow blow and fast acting. So this would be in between the slow and the fast. Circuit breakers. Circuit breakers also provide overcurrent protection for electrical devices, but unlike fuses, do not have to be replaced after they have opened the circuit. A circuit breaker that has opened in response to overcurrent is said to be, and here's the term, tripped. Circuit breakers have the advantage of being reused in a circuit, but typically have slower response times than fuses. This means they are tolerant to short-term overvoltages and won't protect sensitive electronic equipment. This is why surge protectors are needed on sensitive electronic equipment like computers. Okay, this was a quick lesson. We looked at circuit breakers, fuses, and we looked at the different ratings of fuses, and we looked at batteries. So this introduces electronic components. The next section, 3B, we'll be looking at resistors.